Okay, we will start with the first topic, energy and chemical change. Under this topic, we need to know about energy, heat, and specific heat capacity and the related questions. First of all, we need to know about from section 1, energy. Under this topic, we need to know about describe the energy changes resulting from physical change and chemical reaction, also from nuclear reaction. And we need to solve problems related to this. The main keyword from these topics are energy, law of conservation of energy, chemical potential energy, heat, calorie, joule, and specific heat. First of all, we need to know about the term energy. Before starting law of conservation of energy, we need to define what do you mean by energy. Energy means energy. In physics, we studied what do you mean by energy? It is the ability to do work. If we want to do some work, we need the energy. So energy is defined as the ability to do work. We have different forms of energy. We have different forms of energy. The different forms of energy, the familiar words are radiant energy. Radiant energy that is related with sun. Another example of energy is nuclear energy. Nuclear energy that is related with nuclear reaction. We have potential energy also. Potential energy is related with the position we studied in physics. What do you mean by potential energy? So the potential energy is related to position. For example, if you are keeping some water, in a tank, this is the tank that I kept at a height. This is the tank. I kept some water. This is the ground level. So I kept water in the tank. So that means it related to the position. So the energy related over here, it is the potential energy. When the water is flowing, that means what? It changes into kinetic energy. So what do you mean by kinetic energy? Kinetic energy is related to movement. So certain forms of energy we discuss. The first part of energy, the examples for energy are radiant energy, nuclear energy, potential energy, and kinetic energy. Potential energy is related to position and kinetic energy is related to movement. After that, we need to know about the law of conservation of energy. What do you mean by law of conservation of energy? We studied it in physics also as well as in chemistry. What do you mean by that? When a chemical reaction is taking place, what happens? The energy can be converted from one form to another. For example, if there is a chemical reaction, the chemical compound, it contains potential energy. The chemical compound, the potential energy is stored. The stored energy, which is called the potential energy. During chemical reaction, what happens? the potential energy get converted into heat or light or some other forms of energy. So what do you understand from this? Energy, it is first before reaction we have potential energy. After the reaction we are getting heat energy or light energy. That shows that energy can be converted from one form to another. It is not destroyed or not created. No other, it only the form, it just converted from one form to another. It won't get lost or it won't get gained. Okay. Now next one, we need to know about potential energy. So we define what is energy. Energy means it is the ability to do work. After that, we define about different forms of energy. Example, radiant energy, chemical energy, nuclear energy, potential energy, and kinetic energy. After that, we define about the law of conservation of energy. Energy can neither be created nor be destroyed. It can be converted from one form to another. Okay. Now next one, we need to know about the potential energy. I told potential energy means it is the stored energy. Energy that is stored in the molecule. If you are taking a chemical compound, energy stored in the compound. That energy we call it as potential energy. So the potential energy, for example, the carbon plus oxygen, it form carbon dioxide plus heat. So before reaction, we have the potential energy. After the reaction, the potential energy get converted into heat energy. Okay, so that means during a chemical reaction, the energy get converted into one form into another. We have another form of energy, we call it as thermal energy. So thermal energy means, what do you mean by thermal energy? From the word itself we can understand thermal means something related to heat. So during chemical reaction, some reaction they need energy to carry out the reaction. So those reaction which absorbs heat, we call it as endothermic reaction. So those reaction which absorbs heat, we termed it as endothermic reaction. There are some reaction in which heat energy gives out. So if they gives out heat energy, we call it as exothermic reaction. So thermal energy is related to the term heat. There are two different types of heat related reaction. Those reaction which absorbs heat, those reaction which gives out heat. So the reaction which absorbs heat, we call it as endothermic. The reaction which gives out heat, we call it as exothermic reaction. For example, if I am talking about endothermic reaction, for example, A is a compound, it absorbs heat and form B as a compound. So when you look at this one, it absorbs heat. It absorbs heat. So when it absorbs heat means that reaction we called it as endothermic reaction. Another example for exothermic reaction, if I am writing for exothermic reaction, A gives B plus it releases heat. So in this reaction, it gives out heat, that we called it as exothermic reaction. So what do you mean by endothermic and exothermic. How can you identify from the reaction will it be exothermic or endothermic? In endothermic reaction, the heat is on the left hand side, and in exothermic reaction, the heat is on the right hand side. In this question, when you look at this question, how energy changes from one form to another in an exothermic reaction? In an exothermic reaction, what happens in an exothermic reaction? What will happen during a chemical reaction? What will happen during exothermic reaction? The energy get converted into one form to another. Exothermic reaction. What is happening? It gives out heat. What happens during endothermic reaction? The heat energy get absorbed. Okay, with example I will tell you. For example, carbon plus oxygen, it gives carbon dioxide plus heat. When a reaction is given like this, from that we can understand the heat it is on the right hand side. That means it is an exothermic reaction. Another reaction, if I am writing another reaction like this, CaCO3 plus heat, it forms CaO plus carbon dioxide. When you look at this reaction, the heat, it is on the left hand side, that shows that it get absorbed, so it is an endothermic reaction. So looking at the reaction itself, we can understand whether it is endothermic or exothermic. For exothermic, the heat gives out, so it will be on the product side. During endothermic reaction, the heat get absorbed. That means the heat it is on the reactant side. These are called the product. Product means which is on the left hand side, and these are called the reactant, which is on the left hand side. So left hand side are called the reactant, the right hand side are called the product. So here calcium carbonate, it is on the left hand side, so it is called the reactant. Calcium oxide and carbon dioxide, it is on the right hand side, so we call this as the product. Okay. Now next question, we can check with the next question. How the light and heat of a burning candle are related to chemical potential energy. This is the burning candle, student. This is the burning candle. So before reaction, it has the potential energy, right? The potential energy is stored. Now after the reaction, what will happen? After the reaction, it is burning. Burning means combustion. When it burns, when the candle burns, it releases heat and light. It gives out heat energy. So what do you understand from this? How the light and heat of the burning candle are related to chemical potential energy. Before reaction, the potential energy is stored. After reaction or during the burning process, these stored potential energy get converted into heat and life, which result in an exothermic reaction because heat is given out, so it is an exothermic reaction. So before that, what all points we discussed in energy? We discussed about energy. First of all, we need to know about energy. What do you mean by energy? Energy is the ability to do work. Second point, what are the different forms of energy? We have radiant energy. The radiant energy is related to sun. We have nuclear energy. It is related to nuclear reaction. We have chemical energy which is related to chemical reaction. We have thermal energy which is related to heat energy. We have potential energy which is the stored energy. We have kinetic energy which is the moving energy. When a substance gets moved, it is kinetic energy. After that, we discuss about two types of thermal energy. So the thermal energy is related. Thermal energy is related to the term heat. We have two types of heat related reaction, exothermic reaction and endothermic reaction. Exothermic reaction, it gives out heat energy, and endothermic reaction, it absorbs heat energy. After that, we discuss about from the equation how can you identify exothermic reaction. If the heat is with reactant, then it is an endothermic reaction. If heat is with the product side, then it is exothermic reaction. We define the law of conservation of energy. What is a law of conservation of energy? Energy neither created nor destroyed. It converted from one form to another. This is the first part what we discussed before with the energy term. So in this chapter, the first part is energy that we already discussed. Second part of this topic is the heat. So first of all, we need to know what do you mean by heat? Heat means the process of energy flowing from warmer object to cold object, warmer object to cooler object. For example, you have two beakers. You have two beakers. Equal amount of water. This water, it is at 100 degrees Celsius. This water, it is at 25 degrees Celsius. You mix both the water. When you mix the water, now the temperature changes to 50 degrees Celsius. So what do you understand from that? Before you have 100 degrees Celsius, you have another beaker with 25 degrees Celsius. When you mix, the temperature remains constant at both the beaker, the temperature remains constant at 50 degrees Celsius. That shows that energy, the movement of energy is from hot object to cold object. This is the water, right? You are mixing. So what happens? The energy moved from hot object to cold object until both the temperature remains the same. So how can you define heat? Heat is the process of flowing energy from warmer object to cooler object. Those which is at high temperature, we call that hot object. So the heat flows from hot object to cold object. So heat can be defined as the energy. It is the energy which flows from hot object to cold object. So what happens during this reaction? The hot object energy is lost. Cold object, the energy is gaining. So the warmer object loses energy, so its temperature decreases. The colder object gains energy, so its temperature increases. So the hot object loses energy, the cold object gains energy. When you are mixing, the temperature of hot object decreases. Look at 100 degree changes into 50 degrees Celsius. Before 100, it changes into 50 degrees Celsius. So the hot object, the temperature decreases. What about the cold object? 25 degrees Celsius changes into 50 degrees Celsius. For the cold object, what happens? The temperature increases. So this is heat. Now we need to know about what are the units used to measure heats. In physics, you studied about what are the basic units needed to measure heat. Okay. The SI unit of heat, it is joule. SI unit means standard international unit. It is joule. The bigger unit of joule is kilojoule. The bigger unit. Another unit of heat is calorie. Bigger unit of calorie is kilocalorie. Another unit of heat is nutritional calorie. So what are the units of heat? I will replace this. Okay, what are the units of heat? The SI unit of heat is joule. This is the standard unit. Another unit of heat is kilojoule. So the joule, it is represented by the letter J. Kilojoule, it is represented by the letter Kj. Another unit, it is calorie. We represent it by the letter cal. Another unit of heat, it is kilocalorie. It is represented by the letter kilocal. Another unit, for example, in food packets, all this, we are using the term nutritional calorie. So nutritional calorie, we can represent it by calories. So these are the important units of heat. The important units, the SI unit of heat is joule. Now we need to know about the conversion. Very, very important, the conversion unit. So for that we need to know about the conversion unit. 1 joule equals 0.2390 cal. 1 joule equals 0.2390 cal. Cal means calories. 1 cal, which is equal to 4.184 joule. 1 calorie equals 1 kilocalorie, which is equal to 1000 calories. This we need to know. Very important, this conversion. Before that, we need to know how can you define calorie. Calorie, how can you define? So the calories can be defined as the amount of energy required to raise the temperature of 1 gram of water by 1 degree Celsius. What is the condition for calories? It should be 1 gram of water. It should be water by 1 degree Celsius. That is the condition for calorie. So the calorie, it is defined as the amount of energy required to raise the temperature of 1 gram of water by 1 degree Celsius. Apart from this conversion unit, we need to know about 1 kilojoule equals 1000 joule. 1 kilocalorie equals 1000 calorie. Similarly, 1 kilojoule equals 1000 joule. So before that, what we need to know about it is, so first, second part we discuss about heat. What do you mean by heat? Heat is the form of energy, flow of energy from hot object to cold object. Now, what are the units of heat? The standard international unit, it is joule. It is represented by the letter J. Other units are kilojoule, calories. This is the small unit. The bigger units are kilocalories, and nutritional calories. Unit conversion is very important. We need to know about the unit conversion also. It's a quick recap of unit conversion. We have joule, cal and kilocalories. So 1 joule equals 0.2930 cal. 1 cal equals 4.184 joule. 1 calories equals 1 kilocalorie, which is equal to 1000 cal. And we have 1 kilojoule equals 1000 joule. So this much conversion we need to know. Okay. Now we will solve one textual question. A fruit oatmeal bar contains 142 nutritional calories. Convert this energy to calorie. So look at these conversion factors which we have to know about the conversion factor. We know that 1 joule equals 0.2390 cal. We have 1 cal equals 4.184 joule. We have 1 calorie equal 1 kilocal, which is equal to 1000 calories. And we know that 1 kilojoule equals 1000 joule. Now we are looking at the question. Okay. First of all, we need to highlight. A fruit oatmeal contains 142 nutritional calories. Convert this energy to joule. Convert this energy to joule. So what do you understand from the question? We need to convert the nutritional calories calorie to calories. So the nutritional calorie, it is represented by calorie. The calories, it is represented by cal. So our conversion is from calorie to cal. Look at the table. What is the relation between them? Calorie to cal. So this is the relation. 1 calorie equals how much cal? 1000 cal. Pick up the relation. 1 calorie equals 1000 cal. They give 142 nutritional calories. So 142 nutritional calorie is equal to how much cals? Take it as X. Okay. So what step we did? First, we need to take the relation because they ask you to convert nutritional calorie to calories. So 1 calorie equal 1000 cal from the relation. The given point is 142 is how much cal? Take it as X. So what we have to do? Cross multiplying. So 1 times X equals 1000 times 142. So what is X? Equals 142,000 cal. Okay. So what we have done? We first write the relation calorie to cal. Take the relation 1 calorie equal 1000 cal. The given question, it is 142. Take it as X. We are cross multiplying. 1 times X is X. 1000 times 142. You are getting 142,000. To convert it into the standard form, what we have to do? This is 1, 2, 3, 4, 5. So I can put 1.42 times 5 figures I moved. So it is 10 to the power of 5 cal. This is your final answer. Okay. We will do certain example questions also. For example, they ask you to convert. There is one question, conversion factor. We will do some conversion factor question. So they ask you to convert some value given here, 230 nutritional calories. Okay. They are asking you to convert 230 nutritional calorie to cal. So here again I am writing the relation 1 joule equals 0.2390 cal. 1 cal equals 4.184 joule. 1 calorie equals 1 kilocalorie, which is equals to 1000 cal. Now look at the point. What they asking? 230 nutritional calorie. This is equivalent to nutritional calorie. To calorie. So this cal is equivalent to calorie. So I am taking the relation nutritional calorie, it is equal to calories, and the calorie is equivalent to cal. Now take the relation 1 calorie equals to 1000. So 230 nutritional calorie, take it as X. Now we need to cross multiply. 1 times X equals 1000 times 230. So which is equal to 230123 cal. How can you write it in the standard form? 1, 2, 3, 4, 5. So 2.3 in times 10 to the power of 5 cal. Another example. Another example. An exothermic reaction, for example, they gave 85.5 kilojoule. They ask you to convert into kilocalories. So kilojoule, they ask you to convert kilocalories. So again I'm writing 1 joule equals 0.2390 cal. 1 cal equals 4.184 joule. 1 calorie equals 1 kilocal, which is equal to 1000 cal. 1 kilojoule equals 1000 joule. Now look at the relation. Kilojoule to calorie. Kilojoule to calorie. Kilojoule, we need to convert it into kilocalories. So what we have to do? First one, we need to convert kilojoule to joule. Kilojoule to joule. Joule and calories are related. So joule get converted into cal and cal get converted into kilocal. This is the sequence. Understand? First, you have the kilojoule. So kilojoule is related to joule. Joule is related to cal. Cal is related to kilocal. So this sequence you have to make. So step 1, I need to convert kilojoule to joule. So we know that 1 kilojoule equals 1000 joule. So 85.5, take it as x. Cross multiplying. X times 1 equals 1000 times 85.5, which is equal to 85500 joule. This is part 1. Now what we have to do? We need to convert. So we got in joule, we need to convert joule to cal. So we know that joule to cal. Joule we need to convert into cal. So 1 joule equals 0.2390. So 85500 is how much? Take it as x. Cross multiplying. So how much you are getting? 1 times x equals 1 times x is x equals, you cross multiply, 0.2390 times 85500. So we are getting 2390 times 85500. So you are getting 20.2434.5 cal. But they are asking you to convert cal to kilocalories. So how can you convert cal to kilocalories? So that relation we need to take. So what's the relation we need to take? We know that 1 kilocalorie equal to 1000 cal. You have 2434.5 is how much? Sorry. So here 2434.5 cal is how much kilocalories. Cross multiplying. So 1 times 20434.5 equals 1000 times x. So here divided by 1000, here also divided by 1000. You can use the calculator. So x equals, you will get the answer 20.434 kilocalories. This is the answer. So what we did here, they asked you to convert kilojoule to kilocalories. So the sequence you have to make, kilojoule is related to joule. So kilojoule to joule. Joule is related to cal. So joule to cal. Cal is related to kilocalories. So that way you need to take the conversion. So first you have to pick 1 kilojoule equal to 1000. So 85.5 cross multiply. You will get the answer. It is in joule. Once you get in joule, then correlate with cal. 1 joule equals 0.2390 cal. So 85500, take it as x, cross multiplying, you will get the answer. It is in cal. Once you get in cal, you need to convert into kilocalories. So cal and kilocalories, 1 kilocalorie equal 1000 cal. So 20434.5, take it as x, cross multiplying, you will get the answer. So the conversion factor is very, very important. We know the conversion factor. Again, we will do one more question related to the conversion factor. First, we will do some simple conversion. 2 joule you need to convert into cal. 2 joule to cal. So here we need to write the conversion factor. We know that what are the conversion factor here? 1 joule equals 0.2390 cal. 1 cal equals 4.184 joule. 1 calorie equals 1 kilocalorie equal 1000 calorie. 1 kilojoule equals 1000 joule. Now look at this one. Here pick up the point, the step 1. What is our step 1? Here we need to convert joule to cal. So pick up the relation joule to cal. So this relation I am taking. This is joule to cal. So I am taking the relation 1 joule equals 0.2390. So 2 joule equals, take it as x, cross multiplying. So 1 times x equals 0.2390 times 2, which is equal to 0.1874. That much cal. Okay. Another example I am showing. They are asking you to convert 4 calories or 0.24 calories to joule. So pick up the relation calorie to joule. This is our relation. So cal you need to convert into joule. So 1 cal equals 4.184 joule. So 0.24, take it as x. 1 times x, which is equal to x, equals 4 times 4.184 times 0.24. So what will be the answer we are getting? 4.184. 4.184 multiplied by 0.24, we are getting the answer as 0.87864. It is in joule, so it is joule. Now sequence factor we need to check. We need to convert 3 joule into 3 joule into nutritional calorie. So nutritional calorie, this is the nutritional calorie. It is related to cal. Cal is related to joule. So first of all, we have to make the sequence. Joule, we converted into cal. Cal, then converted into nutritional calories. So first we take the sequence joule to cal. Joule to cal. We know that 1 joule equals 0.2390. So 3 joule equals, take it as x, cross multiplying, x equals 0.2390 times 3. So we are getting what we have, we are getting 0.717. It is in cal. Now second sequence, what we have to do, we need to convert cal to calories. So we have cal and we have calories. We are taking the relation cal and calories. 1 calorie equals 1000 cal. So 0.717, take it as x. Cross multiplying, x times 1000 equals 1 times 0.717. So divided by 1000, divided by 1000, so we are getting x equals 0.1717. This much. So this much it is the calories. So whenever we are getting, we need to make a sequence like this. This table is important. 1 joule 0.2390 cal. 1 cal 4.184 and nutritional calorie equals to 1000 cal. So here they are asking you to convert joule to nutritional calorie. So think about cal and nutritional calories are related. Cal is related to joule. So first of all, you convert joule to calories. 1 joule equals 0.2390 cal. So 3 joule equals how much? Cross multiply. You are getting the answer. After that, you need to convert cal to calories. We have the relation 1 calorie equal 1000 cal. So 0.717 cal equals how much? You will get the answer.